So we are on number 41 in your packet. If you look at 41 for just briefly, it is about finding degrees. All right, so I am going to try to figure out how many degrees would work for this. Well, if I knew how many degrees it was with a calculator, you could find out how many degrees it is really easy. And then I just have to find tangent of that many degrees. Don't talk now. And secant of that many degrees. All right, so how do you do this on your calculator?
Sine.
Not sine. Inverse sine. Grab your calculator right now. Figure it out. Inverse sine of negative 2/5. All right, now could we do this by hand? Yes, we could. And I'm just trying to tell you the fast way is just grab your calculator, figure out the degrees, then find tangent and secant of it. Now, secant is not a button on your calculator, though, right? So you'd find cosine's answer and then flip it. Okay. Now, here are some other things they're telling you. By saying cosine is greater than 0, they're trying to tell me all students take calc. If cosine is bigger than 0, then that means cosine is positive. That's here and here. Sine is also negative. So therefore, sine must be negative here and here. Where do those overlap? Down there. So that's where my triangle would be if I was going to make a triangle. And sine is opposite over hypotenuse, so opposite would be negative 2, hypotenuse would be 5, and I could figure out this sine right here using Pythagorean theorem. So I could do it that way if I wanted to. All right, so there's some thoughts on number 41. Now, if you want the answers, of course, hopefully you've already got that answer key, and you would check it based on that. Of the functions, sine, tangent, cosecant, cotangent, which are odd, even, continuous. Okay, odd and even is one topic. Continuous is totally different. Let's talk odd even for a second. Do you remember that sine, if you did this little negative thing, that it came out to negative sine? Does that ring a bell? All right, what else was like that? Tangent. And all their evil twins act the same way, right? So what is the evil twin of sine? Cosecant. What is the evil twin of tangent? Cotangent. So all of these guys are going to act the same way, and that's odd. Those are all odd ones. They're all odd functions. The ones that are even are the other ones, which would be what? Cosine. And its evil twin, which is what?
Cosine.
Not the evil twin of cosine is not cosine.
Well, I thought you were thinking like a negative thing.
Secant. All right. So bottom line is those are odd, and these are even. So which of these right here are odd and even? You can figure it out from what I just told you. Now, how about continuous? Continuous means, like, if I just graph sine for you quick, I think you'll quickly notice that it's either continuous or it's not. Watch. Sine. Do you get the idea it's continuous? This keeps going and going and going and going and going with no breaks. Give me an example of something that's not continuous. Tangent, because tangent is in little chunks, and you have to start over again on tangent. So here's tangent, dotted line, there's tangent, and then I got to start over again over here and do it again. Get what I'm saying? That's not continuous. So of course, the other ones that are like that, cotangent is not continuous. How about cosecant? What is cosecant right on top of? Sine. So here's sine. Cosecant would be like this. Does that look continuous to you? No. All right, good enough. I think you get those concepts. Next thing, evaluate. These are all about those inverses, okay? Do you see the inverses here, the -1, and the arc means -1, okay? All right, so those are all inverses. Do you remember those rules about what they can be and what they can't be? Remember this thing where sine and tangent are only allowed from here to here? Remember that stuff? That's going to come into play now again. So this is sine and tangent. What was the oddball that was up here? So the degrees we're talking about here, the degrees are limited to between 0 and what's this over here? Pi. And these guys are limited, and they were sine, this was cosine, and tangent. And again, these are all the inverses of inverse sine, inverse tangent. And the tangent, by the way, remember, could not actually touch. And it was, this is pi over 2, and this is negative pi over 2. All right, so moral of the story is this. When you're doing one of these problems, you need to limit yourself to only being in those zones. All right, so I'm trying to figure out how many degrees these are. Now, your calculator can do this, but it's not smart enough to know where it's allowed and where it's not allowed. what I'm talking about? If I just type this into my calculator, I can't just trust that it's automatically going to know where it's allowed and where it's not allowed. Okay? You should be smarter than the calculator. All right, so let's do this one right now. Don't just go to your calculator and get the answer and figure, oh, that must be it. You have to figure it out step by step. All right, all students take calc. Where is sign positive? Well, sign isn't positive here. So where is sign negative? That's a spot where sign's negative. And that's a spot sign's negative. Now think about this. Where is inverse sine actually allowed? Only in there. And so therefore we must be in here. All right, so I'm going to make a triangle that kind of goes that way. All right. So now I'm going to say if I have a triangle that goes in here and it has an angle I don't know, and its sides are sine is opposite over hypotenuse, the opposite side's -1. Does that kind of make sense from this picture? And the hypotenuse is 2. If it's a 1 and a 2, what's that other side probably? Square root of 3. And so that means that we are in a 30, 60, 90, so that must be a 30-degree angle. So if you wrote 30 degrees and you look for it on the ABCD and it's one of the choices, you'll be like, yeah, must be right. But you're wrong. Because why? Because why? Because it's negative. Now, some of you might be saying, wait a minute, I thought we had to go all the way around the horn and do this thing like this. In the directions, if they say that they don't want to allow negative answers, then you'd be forced to do something like that. But we don't have those directions. It just says evaluate. It doesn't say answer has to be between Okay, so we can figure this out as, I guess it's right here, and the answer is -30. Done. Good question. Doesn't say in the directions, therefore you could give degrees or radians and have a right answer. Again, you got multiple choice here, so if you had it, you aren't going to have one where there's an answer in degrees and an answer in radians is exactly the same. Otherwise, both of them would be right. Unless the directions in the problem say, give the answer in radians. Okay, let's do another one of these where there's like a sign inside of a sign or whatever. All right, so let's go and turn to J as in jukebox. All right, so on this one, yes, the arc means -1. In here, is this answer going to be degrees? Or is it going to be sides? It's going to give me sides in here. I will get sides. Because if it has a little -1 like this, then the answer must be an angle, but it's not one of those. So therefore, it must be giving me sides. So it just wants me to do tangent of pi over 4. Well, if I wanted to, I could do one of these, the old unit circle. Remember this? Pi over 4 goes right up here. Do you happen to remember what point that is at? Root 2 over 2 and root 2 over 2. And if I want the tangent of that, tangent is the sine over the cosine, which would be, well, it doesn't really matter because they're the same. It would be something divided by itself. And this is 1. So well, the answer to this is 1. All right, 1 what? Is it 1 degree? It's just the number 1? 1 over 1. Okay, so if I give it cosine -1 is 1 over 1. Why is that any better? Because it reminds me that my sides are 1 and 1. All right, where would we have... Here's the question this is really asking. Cosine of what degrees would give me 1 over 1 for my sides? It's going to be one of those little collapsing ones, yes. It's going to be collapsing triangle. All right, so now if I do this, cosine of theta is equal to 1. I'm going to draw my picture. I'm going to say, all right, where is inverse cosine actually allowed? Here and here. Where is cosine positive? All students take calc right there, so it must be in here. All right, so I got a triangle that's in here, and the sides are ka adjacent over hypotenuse. The adjacent side is 1, and the hypotenuse is 1, and this side would have to be 0, right? It would collapse down, and it would end up being just, this side would kind of like go, no, I'm gonna, yeah, that's not gonna work so good. Anyway, it collapses down so that's right there. So that point is over 1 up 0, and what is the cosine It's the x, and so it's right there. And so how many degrees are we at anyway? 0 degrees. What would also be a right answer? 360. What would also be a right answer?
420.
If you wanted to say it in radians.
Pi
0 or 2 pi.
0.
Not 0. Oh, 0? I guess you could say 0 pi. That's fine. All right. Moving on. Let's go to the 44 section. This is the kind. It confuses me a little bit when I see these because I'm thinking, all right, so they want an angle, but they're not giving me any sides, but they kind of are giving you sides. X over 1. And now I'm supposed to figure out an angle for that. So then I start by saying, okay, where is tangent allowed, or inverse tangent allowed? It's allowed in this zone. And all students take calc. This doesn't appear to be positive or negative for tangent. I mean, the x could be positive or negative, couldn't it? So I guess I'm going to default back to this one. I'm going to make it in this quadrant. Okay, so now I've got my little triangle here. And if tangent is opposite over adjacent, this must be the opposite, this must be the adjacent. Opposite is x, adjacent is 1, and I don't know what this is. That's the whole point. You got to figure this one out. Close. 1 squared plus x squared, and then you forgot the most important thing at the end. Square root of that. Okay, so this right in here is the square root of 1 squared plus x squared. Basically, all it is based on that squared plus that squared has to equal this squared. All right, so there we have it. That's that side. Now I want the sine of that. The sine in the same little triangle. Sine is opposite over hypotenuse. So that would be x over the hypotenuse, which is square root of 1 plus x squared. Why not 1 squared? Because 1 squared is 1. Okay? If this was in my multiple choice answers, I'd take it. We haven't been pushing the whole rationalizing the denominator thing this year because apparently in AP Calc it's not as big of a deal as it used to be. So, in fact, apparently, I believe I understand that if you don't rationalize your answer, you'll still get it right. So kids that try to rationalize it often screw it up and then they get the problem wrong because they did something they didn't even have to do. So, kind of de-stressing the rationalizing denominators. All right, moving on. This one was a tricky one, but I think I can explain it to you. All right, so the graph of this is a sinusoid, which means it goes like this, right? With a period of 45, that means from peak to peak, or valley to valley, this distance is 45. It goes through the point 6, 0, over 6, up 0. I'm going to pick that to be this spot right here. I'm going to say that that's at over 6 up 0. So that means my axes would be running right like this, right? And I should actually be just touching there, but forgive me for that one. And my axes can be like running like this. I don't know exactly where that axis is. All right, so now, when they say this, f of 6, did they tell me that x was 6 or that y was 6? That's the x. So x is 6. So if x is 6, isn't that this point right here? So what is f of 6? 0. See, they're just telling you that x is 6. So it's just like saying, well, if x is 6, what's y? And we already know that one. It's right there. So this answer is given right there. It just is asking which of these can we figure out. So we can figure that one out. Can we figure out f of 0? That has told you that x is 0. What do we know about x is 0? X is 0 is called the y, what? Intercept. Can I tell what the y-intercept is? No, because I don't know how high this thing goes. Nothing in this directions up here told me how high this thing goes. If it told me its maximum, then I could probably figure it out, but it never tells me how high this thing goes up. So I don't know what the y-intercept is, so I cannot figure out that one. And the last one, at first I thought you couldn't figure it out, but then I realized what they're trying to do with this is make me think about how 96 is really based on 45, kind of. Do you get how that's 2 45s? And then the 6? So do you get how that's the same as f of 6 plus f of 90. And why 90? Why do we care? Because the period is 45. So that's saying move over 2 sets of 45 and you're at the same spot you were in the first place. See, if I move over that, that's 45. And if I do that again, I'll get another one that's the exact same. So wouldn't this answer be exactly the same as that answer? Because it's the same exact thing, it's just moved over. The x, remember x is this way, the x is bigger by 90, which is 2 periods. So that's moved over 2 periods. So I can figure that one out. All right. Moving on. If tangent of theta is negative 5.32, what is the cotangent of theta? All right. This one. I'd be thinking about, well, tangent and cotangent are really a lot alike, aren't they? If the tangent of theta was 1/2, let me just keep it simpler, then what would cotangent of theta be? Not totangent. Cotangent of theta. It'd be 2. You just flip it, right? So, just take this and flip it. So you got 1 over negative 5.32. It's that easy. All right. Now we're on to the investment stuff. So we're going to do that after a short little break here. Okay, we're back from our little break work time there, and here is number 47. On these, what I mainly want to do is go through that list of little formulas with you so you know which one to use when. Because you are going to have a list of formulas on the test. The very front page of the final is a tear-off sheet that you can use that's got formulas on it. Okay? So you won't have to memorize the formulas. You'll just have to know which one to pick. What is the key word in number 47?
Continuously.
Continuously. That's correct. It is this one right here.
And also angular too, right?
Okay, and continuous is huge just because the only formula that is used when it's continuously, it boils it down to one formula. It's the one that's got E in it. Okay, so look on your formula sheet. It's at the very front of your packet. The very front of your packet, the back side of the very front page. Yes, it's not just PERT though. What does it say? A equals B, E to the RT. Yep. All right, so now I just need to stick the numbers in the right spots and it'll be a piece of cake. Or will it? So once you stuck in the 45,000 here, and the 15,000 here, and the E is just E, and then it's R is, I don't know what that is. E I know, it's on the calculator, it's 2.7. And the T is time, which I do know, 30. How do I get that R alone now? You're right, so you'll have 3 equals E to the R times 30. Now, though, I'm left with the hard part. How do I get that thing out of the exponent? There's an X in the exponent. That's exponential. How do you fix exponentials? Logarithms. Now, that what you said would have worked too. But the logarithms, logs help you with these. Log base E of 3. See what I'm doing here? This to back to that. You should be able to do these. Is equal to R times 30. Then your calculator would be used to get that part. ln of 3, and then you just have to divide by 30, and it's a piece of cake from there. But this really does come down to knowing logs, actually. All right, so I'm going to show you that one more time in a little bit different form. If it had been like this, e to the 5r is equal to 20 or something. How do I get that e alone? Not the e, sorry, the r alone. Log base e of 20 equals 5r. And then I do ln 20, and then I divide by 5. Get the idea? All right, yes?
If you have PERT,
Yep.
like let's say R and T, they both have PERT. If you do it for the first one, or would you multiply the two and then do that?
All right, which ones do you know? A, P, R, or T?
Let's say you know A.
Say that's 80. Okay.
Then let's say you know R and T.
Okay. Say R is like 2 and T is like 7.
Multiply the first, or do you do the power of 2 first?
All right. This part, if you know both of these right here, then you can just say e to the that. It's just a calculation. It's just a number.
To the 14th?
So it'd be e to the 14th, and you'd have like e on your calculator. It's 2.7 blah, 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 and then you put that to the 14th. So then it's just get that alone. Okay. We're going to divide by that on both sides. All right. Back to where we were here. This one involves, you know what? Instead of going through each one of these finance problems, I'd rather go through the formulas with you and say, when should we use what? This one says compounded monthly. If you look at your list of formulas, do you see the formula that involves compounding monthly? There are several formulas on that sheet.
This is the second one.
Read me the second one. What is it?
A parentheses 1 plus R over N parentheses and then
That's times
N.
T.
Sorry.
And yes, it's that one, because this one involves not annual compounding. The other one that's just like this but doesn't have these guys in it, that would be for annual. But this one is got some compounding that's not annual, like 12 times a year, like monthly. So since they said monthly, I should probably use this one. All right, so anything that's monthly compounding, you should be thinking maybe this one, unless it specifically says APY or APR. There's a special formula for that. Would you read me the APY formula, please?
I am sorry.
It's on the sheet.
Oh, there's 2.
Yep. You read me the APY one, the top one of the two.
Equals 1 plus R.
R sub 1 equals
Equals parentheses 1 plus R squared over N.
R sub 2 over what?
Oh yeah, over N parentheses.
All right, isn't there a T in there somewhere too?
Got the same thing.
Okay, all right. Then, in the APR, APY formula, you would use this side of it. You'd plug in everything you can that they give you into this side. And you solve for this one. Okay? So they're going to give you a rate. They're going to give you how often it's compounded. And you would solve it. And why are you doing that? So that you can get the rate per year. APY, annual percentage rate. It's not per year, actually. That stands for percentage rate. APY is annual percentage yield, as opposed to APR is annual percentage rate. Anyway, so this an APY versus an APR, this is when you have an investment, like you got big bucks and you're putting them in the bank. And APR is when you're borrowing money. And you're trying to figure out an annual rate when they're giving you a rate that's not annual. So you stick in how often it compounds there, you end up solving it down and get your R alone. Yes? Good question. 0.06. If this is the rate, you put in 0.06. Put it in as a decimal. And an N is the how many times it compounds. Like let's say it compounds weekly, then you'd put 52 there, 52 times a year. If it's compounded monthly, you'd put a 12 there and there. Okay, so it's trying to change something that's not compounded annually into a rate for how much it would be if it was compounded annually, and you solve for that and you get that annual rate. All right, so the finance ones, I just want to remind you that the formulas are on the test and you just have to pick the right one. If it ever says continuously, you use the E one. If it says something like daily, you want one of those ones that has the N in it so that you can you can compound it more than annually. You can compound it daily, which would be 365. Okay, so let's move on through the finance ones to convert to DMS. This is super simple as pie if you know the right button on your calculator. Would you please grab your calculator and look with me for the angle button? It's right next, it's above apps, right? And once you're in the angle menu on your calculator, you have this button. That means change to DMS. All right, so if you want to change something into, which is this DMS stands for degrees, minutes, and seconds. This is a decimal, which is not in degrees, minutes, and seconds. It's just degrees. Do you get the difference? All right, so if this one's in degrees, how do I change it? You would type in 35.2 and then label it as degrees in that angle menu. Once you've got it on your calculator as 35.2 degrees, then you can hit the change to GMS button. It's not a button, it's on the menu for angles. Change to GMS, and once you do that, it will tell you your answer as 35 degrees in like 1 minute and 12 seconds or whatever. All right, one other quirky thing about that is, do you remember where seconds are on the calculator? It's in a weird spot. It's right above the plus key. Look above the plus key. See it there? That little double dash mark that looks kind of like this, that's for seconds. It's above the plus key. It's not on the angle menu. I don't know why. Seems really dumb to me. Okay, so if you're converting something to degrees, like this is in radians, and I want to change to degrees, it's either 180 over pi or pi over 180. And you just got to figure out which one makes sense. If I want degrees, then I put degrees on top. If I want my degrees to cancel so I'm left with radians, then you put the degrees on the bottom. So like in this one, I put the degrees on the bottom. It's always pi over 180 or 180 over pi. Okay? All right, moving on. Name two positive and two negative angles that are coterminal with the given angle. Coterminal means in the exact same spot. So if I was talking 510 and I draw my 510 degree angle, would you agree that'd be 360? And I keep going to get 510, right? This would be 480, and 510 goes down here. It stops there somewhere. All right. Well, if you take 360 away from 510, I would get, what is it, 150? Then that means 150 would have done the same thing if I'd have just gone to 150 in the first place. Or I could have gone backwards to get there. Since there's 30 left here, I take 180 plus that 30, and say my answer is negative 180, and negative 30 makes negative 210, for example. And then you can always, if you want to, go 360 degrees around again, all the way around again. So you add another negative 360 to it. Negative 570, that's correct. And I could always taken my positive 150, and I could have added 360 to that. And I get for 510 again. Well, I guess that's what I had in the first place. I could add another 360 to that and make it 890 or 870. Thank you. All right. I think you get the idea what coterminal means. It's the same spot. You just get there a different way. All right. And we are finally on the last section, the section that is the stuff we just studied, which is most fresh in your mind and therefore should be easiest, except that they're kind of hard problems in the first place. But at least you remember them better. So, no, it's definitely assigned like everything else, but these should hopefully come back quickly. Tangent, you could replace with what, for instance? Sine over cosine times cosine. And then I could see, oh, that's over 1, so I can just cancel off my cosines, and I just have sine left. Done. This one, do you recognize it as one of those deals where you would have a co-function?
Wouldn't that be
Sine.
sine?
In the past, we've used a theta, but it's the same thing. Sine of x. All there is to it. You just got to recognize them. All right, do you remember how if I have sine of negative x, that's actually a negative, and then if I have a negative on the outside and another negative on the inside, negative makes it positive, so it'd be positive sine again. All right, I don't want to go through all of these, but let's do one of the harder ones, like a proving one. This one stumped some really smart kids, so let me help you with it. Number 65A. It's a good question. It is multiple choice final, so can we involve stuff about proofs? You wouldn't have to show your work to get the proof, but they could ask you true or not, couldn't they? Okay, so if you can make it work that it comes out to be this answer, then you could say, yes, that is a true statement. Okay, so it's kind of really more like a simplify question then, and it's just, does this simplify to that or not? All right, so let's do this one. My first thought is that on a proof, you can't just multiply both sides by I can't cross multiply. I can't just multiply everything by 2, like you could on a normal equation like this. I could subtract 2 from each side. You can't do that on proofs. You got to stay on your own side. So I got to stay on this side here until I simplify it enough so that it equals that. All right, so how do I do that? I'm going to think multiplying this by something
Well,
is going to help.
well,
Because the last time we had a problem like this, when we had that, we were thinking, oh, wouldn't it be really nice if it had been like 1 minus sine squared or something with sine squared in it? Because that's one of the identities. All right, so to get this to be squared, I could multiply it. Who's smart enough to know? By not sine. Thank you for trying. Not cosine either. 1, not plus sine. You were warm. 1 minus sine. Now, why 1 minus sine? Because 1 minus sine times 1 plus sine, does that remind you at all of these things where you break them up into x plus 1 and x minus 1? See what I mean? And then you get one of these deals that combined makes a squared. All right? That's why you'd choose to multiply it by 1 minus sine x on both sides. And if you do that on the top and the bottom, you're only multiplying by 1, so it's legal. And then the bottom part becomes 1 squared plus the sine x minus the sine x, which cancels. And the last is minus sine squared. So the bottom of this fraction is 1 minus sine squared. Have you ever seen that before? What's 1 minus sine squared? Cosine squared. It comes from this one. Here's a fact. Cosine squared plus sine squared equals 1. So if I take 1 minus sine squared, I take away sine squared from both sides. Cosine is equal to 1 minus sine squared theta. So this bottom becomes cosine squared. On top, I have 1 minus sine times cosine. On the bottom, I now have a cosine. Yes. Just do one thing at a time. And now this would cancel off one of my two cosines. That was cosine times cosine. All right, so now it's 1 minus sine over cosine, and that's what I wanted. All right? Those are tough. Yes? Good question. I don't think that we are going to do anything, go ahead, with the TMZ solver, is it? TMV? That's different. That's on TV. If you want to know where it is, though, it's under Finance, Applications, or Applications, Finance, TVM solver, time value of money. And that, but I don't think that that's, we're going to use that. I think we're going to be using the formulas. Is there any that you have to use the TVM for? Is there? Oh, but the monthly payment ones, okay. I'm going to pause for a second and see what you're talking about. Okay, I stand corrected. I think looking at some of the answer key, looks like some of these are from that TVM solver. So I should pull up my calculator here. I'm going to do that, pause, and get that up. Okay, here we go. So we are in apps, the red key there on the screen. And then I need to get to finance, so I hit 1. And I'm in the finance, and I'm in TVM solver. All right, so there it is. Now, for instance, on problem number 54, Becky obtains a 30-year, $86,000 house loan with an APR of 9.25 from NBD Bank. What is her monthly payment? All right. Well, if it's a 30-year, we got to put that in somewhere. Do you know where that goes? On the top. N is not 30, though. 30 times 12, which would be 360. Now, you could have put, yeah, you could actually put 30 times 12 in here if you want to. It'll do the math for you, which is kind of cool. The idea? 360. Okay. The interest rate is 9.25, and you actually put it in as 9.25, not 0.09. You know what I mean? Oop, how did I miss a 2 there? All right. Next up, is the present value. The present value of that loan is $86,000. As in, I'm borrowing that presently. Not I'm going to owe that someday in the future. I owe that the first day that I take out that loan. All right, the PMT is the thing I want to figure out. That's the payment. How much do I have to make for payments on this deal? And the future value, what do you think you want your loan's value to be in the future? 0. Doesn't that make sense? I don't want to have any value to the loan. I want it paid off. And payments per year is definitely not 1. It's going to be 12. And the other one will follow automatically from that. If I hit enter, it'll automatically change it to compounding per year 12. Okay, now which one do we want to figure out? PMT. Do you remember how to do that? All right, so I hit second. Oh, you're right, it's not second. It's alpha. All right, and I can't read it on my computer, but I think right above, is it above the enter key? Okay, and it says solve. And there it is, negative 707. What that means is I got to pay down $707 on that loan. Okay? So, does that remind you how to do those? Okay, good. All right, good enough on that. Let's get that. Oh, more on this.
I was not going to buy a house. I was going to live in a cardboard.
That'll work.
Save a ton of money.
Okay,
Live with sewers.
I think that's all I've got for you.